Transforming data. One of the most common things we'll do in our MMUULLEE application is to move data between different forms. Anypoint Platform provides a set of transformers to handle the most common data transformation scenarios. Up to MMUULLEE 3.6, this was the main way to transform a message. And effectively what you see on the right here are the many options you have to perform a transformation, bringing an input type through one of these transformers to produce your desired type. Now, often we run into more complex transformations. And up until MMUULLEE 3.6, complex transformations were handled by either chaining transformers, creating a custom Java transformer, using a script transformer to write the transformation in something like Groovy, JavaScript, Python, or Ruby, or using the data mapper transformer, which had a graphical interface to work with many different data formats. As of MMUULLEE 3.7, we now have a tool called DataWeave. DataWeave is a new way to transform data. It's fully featured and provides a fully native framework for querying and transforming data in Anypoint Platform. DataWeave is powered by the DataWeave Data Transformation Language. This is a JSON-like language that's built specifically for data transformation use cases. DataWeave is powered by the core MMUULLEE runtime. This provides 5 times performance versus some of the previous approaches, such as Data Mapper. DataWeave is also fully integrated with Anypoint Studio and DataSense, and also gives us a graphical interface with payload-aware development. So when would you use DataWeave? Well, DataWeave is a tool that was purposely built to make it easy to write simple to complex transformations. So in MMUULLEE 3.7+, whether you're doing simple one-to-one mappings, transforming hierarchical data models, deduping data, filtering data, grouping and partitioning, joining data across multiple sources, or even streaming inbound and outbound data, DataWeave is the tool for you. All in all, you can use DataWeave for all your transformations, from simple to complex. This will prevent your developers from having to shuffle through a large set of transformers or frameworks. Unless you specifically want to use a framework like Jaxby or Jackson because of existing code bases or technologies, DataWeave is going to be the perfect tool for handling your transformations. Under the hood in DataWeave, you're going to find a connectivity layer and engine that is fundamentally different from other transformation technologies. It contains a data access layer that indexes content and accesses the binary directly, without the costly conversions you typically need to introspect that object. It enables larger than memory payloads, random access to input documents, and gives us a much higher grade of performance than we've previously seen. Along with a powerful engine, it also combines perfectly with our design time environment. The DataWeave Transform message component provides an Anypoint Studio interface to this powerful transformer. The properties view has input, output, and transform sections, both with drag and drop as you can see on the left, and code editors on the right. Along with a powerful engine, it also combines perfectly with our design time environment. The DataWeave Transform message component provides an Anypoint Studio interface to this powerful transformer. The properties view has input, output, and transform sections, both with drag and drop as you can see on the left, and code editors on the right. While developing these transforms, you're also going to get the chance to take advantage of DataWeave with DataSense. So DataSense and DataWeave work together, allowing you to have payload-aware development. What this means is your metadata from connectors, schemas, and sample documents can be used to more easily build out your transformations. This will display input and output sections for incoming and outbound messages. This will aid in your drag and drop graphical editor. As you can see in the bottom right, on the left, you'll see what your input data structure would look like, and on the right, you can see what your output data structure would look like. This will also provide code autocompletion in the code editor. Now let's get hands-on with some transformations in Anypoint Studio. First, we'll use the object-to-JSON transformer to get those database results into a more readable form. We'll then replace it with a transform message component. We'll use the DataWeave graphical editor to change the response to a different JSON structure based on our YAML file. Let's get started. Back inside of Anypoint Studio, let's see if we can get these database results in a more readable form. From our palette, let's go ahead and search for different JSON transformers. Now, coming out of our database is going to be an object, and we want to turn that object into a JSON representation. So we'll grab our object-to-JSON transformer and drag that inside of the flow. With object-to-JSON in place, let's go ahead and save up our application and run it. Once the application is started, let's head back to Postman. Back in Postman, we'll return to our same endpoint. Here we can see the previous results we got with all the scattered data. This time, let's send another send request in. Once we send this new request in, we can see how clean the result set is in JSON format. We can see from the database all the different information about the plain type, the code, and so on. Now that we've got this in a JSON format, let's go ahead and see what we can do with our original API and what type of transformation we want this to eventually become. Let's flip into a web browser and head to the Anypoint Exchange. We can get to the exchange at anypoint.mulesoft.com. And let's go ahead and log in once again. Once logged into Anypoint platform, let's click the navigation in the top left and head to the exchange. Inside of Anypoint Exchange, let's search for our RAML definition. Again, remember we called it American flights. Inside of here, we can see the American Flights API that we had set up previously. Now let's go into the portal and see what the definition of the responses looked like. Once inside of the portal, we'll go to the API reference in the left side, and let's go ahead and open up the Get tab for flights. Inside of the Get tab for flights, let's scroll down and see what our sample response was. So this is a sample response that we had put inside of our example of the API definition. I'm going to copy this to my clipboard and put it inside of a text editor. Now let's flip back to Postman and see if we can make a comparison. Back inside of Postman, we can see that our data structure looks something like this. In bringing back our text editor, we can see that there are some slight differences between the two. In particular, we can see that some of the fields are different, such as code, and this having code 1 and code 2 inside of it. We can also see structurally it's a bit different. If we look inside of the plain section, this is more flat. It has details about total seats and so on, but this has a structure inside of it where it defines plain, and inside of the plain are maps effectively for type and total seats. Now the ideal goal here would be to take this transformation and not just do a simple JSON transform, but do a more specific one that matches our API specification. This is going to be a great use case for data weave. So let's hop back into Studio and get set up. Back inside of Studio, let's make sure the project is stopped. So I'll right-click and stop project. I'll select the object to JSON transformer and delete it. Let's now take the transformation, specifically data weave, and place it at the end of the flow. Inside of our search box here, we can type in transform and drag transform message to the very end of the flow. Now with transform message selected, feel free to double click it to bring up the GUI, and we can see some information about our transform. In particular, notice that it's automatically picked up the database table columns on the left. It is providing us a way to map these to an unknown data type on the right. Now, obviously we want to know what our output data type is so we can start our mapping process. Let's go ahead and click Define Metadata. In the Define Metadata box, we're going to click the Add button to add a new metadata type. For our type ID, let's go ahead and put in American Flights JSON. And then click Create Type. Now it'll bring us back to the Select Metadata box, and let's set up the type that we're going to set. In this case, it's going to be a JSON type. And specifically, instead of a JSON schema, we're just going to provide a JSON example. To get a JSON example in, let's click the Browse button on the right side. And then let's head into our student files. Inside of your student files, you should have a directory called Schemas and Examples. Let's expand Schemas and Examples. Inside of here, let's click the American Flights Example JSON and hit Open. Once you hit Open, it should load all the different fields that it parsed from the example JSON. This is what we're going to use in Data Weave to define our output type. Let's click Select. Now, we don't just have our input that's been introspected, but also an output that we can start mapping to. So let's see if we can start our transformations. Well, one of the great things about Data Weave is we have the ability to drag and drop fields. Let's start off with ID. ID is 1 for 1, so we're just going to drag the ID from the input and put that inside of the output of the JSON. As we drag our elements over, you can see the code on the right beginning to generate itself. Let's do the same thing for price. And now let's do something similar for total seats. In this case, you can see that total seats on the output is part of the plain structure inside of the main structure, and on the input you can see in the flat structure it's just its own field. Let's drag total seats over to total seats inside of the plain JSON, and you can see how the code updates to reflect that. Now let's go ahead and map fields with different names by dragging them from the input section and dropping them to their corresponding item on the output section. While the names might differ a little bit, it should be pretty intuitive which input fields map to which output fields. So the from airport is going to go to the origin. The plain type is going to go under type. Seats available is going to map to empty seats. Takeoff date will map to departure date. And then to airport should map to destination. All right, so now we've got a good mapping in place. We'd also like to map the code. Code should be a concatenation of code 1 and code 2 put together. So let's go ahead and drag code 1 over, and then code 2 over as well. In the code editor, you'll see how it's built out code 1 and concatenated that to code 2. Now we have a transformation defining our output structure in place. Let's go ahead and click on the preview in the right side of our screen. Now, in order to see a preview of how this is going to work, it wants us to create required sample data to execute this preview. Let's click this link. Now I'm just going to double click on the Transform Message tab to make this a bit bigger and easier to see. Inside of here, on my left panel, I now have the ability to define some example fields. This way I can see what the output would be like from a preview perspective. So let's take a moment just to put some sample data inside of here. All right, and now as I've put some data in here, you probably saw on the right side as you were putting data in that it was beginning to create the transformation for this specific element inside of here. In fact, if we were to go in and make another element inside of the sample and copy the whole structure down, put a comma in, you'll actually see that next element in the array show up inside of here. So we can build out as realistic of a preview as we'd like, and as we go through and transform and make changes, we'd see that preview change inside of this dialog. So let's go ahead and double click on the Transform Message tab again to make it a little bit smaller. Now that we've got our transform in place, let's see if we can actually test out this application. We'll do so by clicking in the canvas, ensuring our project is completely saved, and then running the project. Great. Now that our application is running again, let's head back over to Postman and see what we get as far as a response is concerned. Back at our same endpoint, we can see our old data structure inside of here. And now if we hit send, now we have a transform that's compliant with our API definition. We can see the structure in place with the appropriate fields. We can see the additional piece of the plane inside of here that has its own map. And now we're meeting our example specification. Now, what if we wanted to get a little bit more advanced with this? Our API spec didn't just say we could call flights, but also request a specific flight. So if we wanted to request flight 3, let's see what happens. If we hit send inside of Postman, we instantly get a 404 back to our client stating that the resource was not found. Well, this will be something we want to look at next. Now that we've got a transform in place, how could we support more than one operation, more than one endpoint, and further satisfy our API definition?